In the case of square planar crystal field, you can see ligands are coming from 4 directions, each on the x and y axes. So energy on d orbital are degenerated into 4 different levels. dx squared dash y squared has the highest energy, and dxy will be the second highest energy, and dz squared will have the second lowest energy, and dxz dyz has the lowest energy. One key point of this particular crystal field is that the energy gap between first two energies is same as the one in the octahedral crystal field. By this phenomenon, not only square planar complexes but also D8 ligand tends to have square planar crystal field rather than octahedral or tetrahedral due to high stability. The last one is tetrahedral crystal field. There are 4 ligands attached to the central metal in the diagonal way, and that will lead dxy, dyz, dzx the highest energy and last 2 with the lowest energy. Let's label each level as T2 and E. The energy gap of tetrahedral complex is relatively smaller than the one in the octahedral, about 0.44, which is the reason why tetrahedral complexes are usually high spins. And if you look carefully, there is no G on the each energy level, and that is because they don't have inversion symmetry, as you can easily find by drawing. However, CFT has limitations. There are mainly 2 limitations, which is it can't fully explain the spectrochemical series and it only takes d orbital into account. So, what is the spectrochemical series? There is an order of ligands by delta O called spectrochemical series. This is the common spectrochemical series, and the ligands on the right side is much stronger than the left side. If you look carefully, H2O, CO, and H3 like neutral ligands have larger delta O than negative ligands, and CFT can't fully explain this especially. This phenomenon means that the interaction between metal ligand is not purely ionic, which is reverse of the assumption of CFT. Also, the theory only takes d orbital into account, which actually s and p orbitals also does relate on complex formation. And by those, there is new theory called ligand field theory to handle those limitations. And this is the end. Thank you.